Outliers. This data appears to be skewed to the right with more test scores at the high range. 75% of the values, first quartile to the largest value, range from test scores of 88% to 100%, where 25% of the values, the smallest to the first quartile value, or the left whisker, range from scores of 66% to 87%, a larger range for only 25% of the data. If graph data shows a skewed distribution, or distributions have extreme outliers in one direction or both directions, we may need to eliminate potential outliers. An outlier is a data value that is distant from other data values. An outlier may be due to variability in the measurement, or it may indicate experimental error. To determine whether an outlier exists, first find the interquartile range. The interquartile range, IQR, is found by taking the third quartile value minus the first quartile value. An outlier exists if a data value is greater than the third quartile plus 1.5 times that interquartile range, or if a data value is less than the first quartile value minus 1.5 times the interquartile range. Let's take a look at an example to determine whether we do have an outlier or not. So here are the scores from a math test. We have the first quartile value of 88, the third quartile value of 96. Those again are the ends of the box in our plot here. And we're going to determine if there are, in fact, any outliers. The first step is to determine the interquartile range. That's found by subtracting the first quartile from the third quartile, which for this data results in an 8. Next, we will determine a possibility of a large outlier by looking at any data values that are greater than the third quartile plus 1.5 times the interquartile range. The third quartile for this example is 96. We just found that the interquartile range is 8. We multiply that by 1.5. 1.5 times 8 gives us 12. We multiply before we add, and when we add, we end up with 108. It could be considered a possible outlier on the high end if we have a score greater than 108. Well, our largest score was 100, so there are no large outliers. Let's look at the lower end. To determine a possible outlier on the small end or lower end of our data, we need to determine what the first quartile less 1.5 times the interquartile range results in. Our first quartile value is 88 for this set of data, minus 1.5 times 8, the interquartile range. Multiply first, 1.5 times 8 gives us 12, and subtract that from our first quartile value. The result is 76. Possible outliers will occur if they are less than 76. And if you look at this data, we have, in fact, 4 values that are less than 76, which is skewing our data and should not be used to determine any decision regarding this data. With extreme values or outliers of 65, 70, and the 275 scores, the box and whiskers plot could be graphed to note those outliers. And notice the change. We have 75% of the values here and this extremely long whisker, versus now that we've identified the outliers, here is the procedure for identifying outliers. We place dots at outliers which were determined from the procedure we just went through. Our new lowest value is 88, which is our first quartile value. So for this particular set of data, we lost the left whisker. The median, or Q2, still divides the data in half. With little to no whisker on the low side, 50% of the values are in the range represented by the left half of the box. The other 50% of the data is to the right of the median.